So, a pleasant day to everyone. Today we're going to discuss some examples for kinetics of a particle for Newton's second law for the relationship between the force and acceleration. So, for our first example, we have a 50 kilogram crate shown in the figure rests on a horizontal surface for which the coefficient of kinetic friction, mu k, is equal to 0.3. If the crate is subjected to a force 400 Newton, as shown, determine the velocity of the crate in 3 seconds starting from rest. So for our solution, what we need to do first is to draw our free body diagram or the FBD. So given now the crate, so we have your force weight, which is directed downwards to its center of gravity. We also have your normal force directed towards the surface. Then we have your frictional force, which will be opposite the direction of your motion. Then we have your applied force, 400 newtons, which is 30 degrees above the horizontal. So there are no other forces acting on your object in the crate. So we have our FB. So for our next step, we now solve for our summation of forces along x and y. So summation of forces along our x direction. X here is our positive directions. So summation of forces along x. So our motion is moving in this direction horizontally and it is accelerating. We now have summation of x. Fx is now equal to the mass, total mass times your acceleration along the x direction. Okay, so we have now to the right is positive. So forces along the x, we have our applied force 400 should be cosine of 30 degrees. So minus our frictional force equal to mass times the acceleration x. So F is unknown, but we know that the coefficient of friction is equal to the ratio of the friction divided by the normal force. So normal force is not yet known, so we move to the summation of forces along y, and that's equal to mass times ay. So we have upwards positive. Okay. So for the y forces, we have your NF upwards minus the weight, and then we also have the vertical component or y component of the applied force, so that will be plus 400 sine of 30 degrees, and that is equal to mass times ay. But take note, since our acceleration is only along the horizontal, therefore ay is equal to 0. So from here, we could simplify now our equation. So we know that weight is equal to mass times g. So we're given the mass 50. G is 9.81. So we could simplify. NF is equal now to, so this becomes 0. So transpose natin. Weight now is equal to 490.5 minus, that's 400 sine of 30 will give us 200, or NF now is equal to 490.5 minus 200 is equal to 290.5 newtons. Okay? So we use this in this equation. So we'll have now mu k is given at 0.3 equal to the friction divided by 290.5. So So therefore, the frictional force is equal to 87.15 newtons. So from here, we could now apply again our frictional force in our horizontal forces equation. So we have 400 cosine 30 is equal to 346.41. So minus 87.15. That's equal to the mass is 50. Then we have your AX. So AX now is equal to 346.41 minus 87.15. You divide it by 50. You now arrive at 5.185 meters per second squared. So for our motion, so it's moving along the horizontal. So EX is also the total acceleration of the system. So this is not yet our final answer, as what we want to solve is the velocity at 3 seconds. Okay? So to solve now for our velocity, we could apply our kinematic equation, which is Vf equal to Vi plus AT. So it's starting from rest, therefore Vi is equivalent to 0. So Vf now, or V at 3 seconds is equal to a constant acceleration. Okay, so at any position, this is our acceleration. So we have 5.185 meters per second times 3 seconds. Or V3 now is equal to 15.56 or 556 meters per second. So this is our final answer. Okay, so we have example number 2. A car weighing 4,000 newtons goes around an 800-meter curve at a constant speed of 20 meters per second. So if the road is not banked, meaning it's not elevated, so it's flat, what force must the road exert on the tires so that they will maintain motion along our curve? So we are given here your circular curve where the car or the vehicle will travel through. And we are given the radius 800 meters. So it's the radius that's given, it's not the length of the road. Okay, so the 800 meters. So for our solution, we first identify our free body diagram. So for our car, the forces acting on it will be its weight, its normal force, and its frictional force between the road and the tire. So if we're going to inspect our free body diagram, you will come to see that for the weight and the normal force, so we'll have an equation here. And then for the frictional force, you will be seeing that it's not unopposed. So meaning wala siyang iba. So, ma'am, how can we compute now for the frictional force if we cannot derive an equation for the forces along the horizontal? So take note that our car is moving along a circular path. So therefore, its motion is not translational, meaning it's not along the horizontal and the vertical. So the motion of this car is a rotational motion or a circular motion. Therefore, what we will do is to equate now our equation of motion. So we have summation of F is equal to MA. And our direction now will be a circular one. So it's a clockwise direction or counterclockwise rotation. Okay? So with this, since the car is moving along a rotational or in a rotational motion, then our acceleration now will be defined by AC equal to V squared over R. And then for our summation of forces, that will now be equivalent to W minus NF plus the frictional force equal to mass times AC. So take note, Since if we're going to derive our summation of forces vertical, we'll arrive at W equal to NF. Thus, in our equation, W and NF will cancel out, leaving us with F equal to MEC, wherein M is equal to W over G and EC is equal to V squared over R. Okay, so this will now be our final equation. So substituting now the values, we have F is equal to 4,000 newtons divided by 9.81 times 20 squared over 800. So simplifying, the frictional force or the force between the road and the tires will now be equivalent to 203.87 newtons. So this one is our final answer. Okay, so next we have example number 3. A 10-kilogram projectile is fired vertically upward from the ground with an initial velocity of 50 meters per second. So we have this diagram to illustrate our problem. So determine the maximum height to which it will travel if, first situation, atmospheric or air resistance is neglected, and B, atmospheric resistance is measured as F sub D equal to 0.01 V squared, where V is the speed of the projectile at any instant, which is measured in meters per second. Okay, so to start off with our solution, we draw first our FBD. So we have the weight of the projectile, no other forces acting on it. For letter A, so its motion is upwards. So for letter A, we apply our equation of motion, summation of forces equal to MA, and that will be positive upwards. So writing our equation, we have negative W equal to M times A. And we know that W is, or weight is computed as mass times G, which will give us a value of 98.1 newtons. So substituting now the weight in our equation, we now arrive at negative 98.1 equal to 10 times A. Or the acceleration now of the projectile when moving without air resistance is equal to negative 9.81 per meter per second square. So we do not stop here, since what we want to solve is our maximum height. So given now the acceleration computed, and we are given our initial velocity, therefore we could use our kinematic equation, which is equal to kinematic equation, which is B F squared equal to VI squared plus 2AY. So take note, ito yung ginagamit natin, di ba, pag vertical. Pero since Y here is denoted as Z, we could simply change this to Z. So from our previous discussions and from your physics, we know that when an object travels along the vertical, when it reaches its maximum point, its velocity becomes almost equal to 0. So final velocity here will be 0. So squared equal to the initial velocity, 50 squared plus 2 times our computed acceleration, negative 9.1 times our y, which is denoted in the diagram as z. Or z now is equal to 112.42 meters. So this is our answer for letter. So this is the maximum height reached by the projectile when there is no air resistance or atmospheric resistance. Okay, so we move on to the next problem or next situation. B, we now have an air resistance, which is denoted by F sub B. So for our solution, again, we apply or draw first our FVD. So for our object or projectile, we have our weight of the projectile. And since there's a drag resistance, and a drag resistance or air resistance will oppose or retard our motion, therefore our FD or air resistance will now be directed downwards. Okay, so from here, we now apply our equation of motion. So we have summation of F is equal to MA. Let's have upwards positive. So writing this one now, we'll have negative FD minus weight is equal to M times. We know that FD is equal to 0.01 V squared and the weight is 98.1. Mass is 10 times the acceleration. So dividing the whole equation by 10, we can now arrive at an equation for A, which is now equal to negative 0.001 V squared minus 9.81. Or we could simplify this quantity. This becomes positive. So negative, negative. Same din lang siya. And then from our previous discussions, we have said that A can be computed as V times dV. Okay, so A is the equivalent to velocity times the derivative of V. So equating now A, the two equations for acceleration, we now arrive at negative 0.001 V squared plus 9.81 equal to V dV. Okay, so from this equation, we now relate our equation of A in terms of Z as, so we relate A to Z using the equation acceleration times dz is equal now to V dV. So we'll now have negative 0. With that, we could also simplify it. Since we are solving for dz, we could write this as dz equal to V dV over A. Or we now have dz is equal to V dV all over A is now equal to negative 0.001 plus 9.81. Okay, so with that, we can now apply our integration. So for z, that is from the start 0 to a certain height z. And then for v, we started from 50 meters per second. And once it reaches its maximum height z, its velocity becomes 0. So simplifying now, this one, integrating, will now arrive at delta z is equal to negative 500 ln of v squared plus 9.8 or 9,000, 9, 8, 10, from 0 to 50. So, your Z now, or delta H, or delta height is equal to 114 meters. Okay? So, this is now our final answer. So, pwede nyong i-simplify sa ganito or diretso nyo na sa calculator yung value na ito. You'll arrive at 114 meters. Okay, we have example number 4. Two masses, 15 kilograms and 7.5 kilograms, rest on a 45-degree inclined plane as shown. So it's connected by a flexible, inextensible cord. So when the masses are released, what will be the tension T in the cord? If the coefficient of friction between the 15 kilogram block and the plane is 0.25, and for the 7.5 kilogram in the plane will have a coefficient of 0.375. So for our solution, we again first draw our FBD. For our FBD, we have first the weight 1 for 15 kilograms. We have your normal force. Then we have your frictional force for the first block. Then for the second block, we'll have your weight 2, normal force 2, and the frictional force. And aside from that, we also have the tension between the two objects. So for our solution, we start off first with our first block. So we have for the 15 kilogram block. So we'll have summation of forces along the x-axis. That's equal to mass times. So we'll have inclined axis. So we have this as x. This one is y. MEX. So let's assume upwards direction is positive. So for Fx equal to MEX, what are the forces along your x-axis? So we'll have F1. So F1 is directed in this direction. So we're assuming that our motion is sliding down. Okay? So F1. And then we have your tension. And then we have our Wx. It's minus Wx is equal to the mass times Ax. So we'll have F1 plus tension minus Wx is 15 times 9.81, and that will be equal now to sine of 45 is equal to MEX, that's 15 times AX. So we have 1, 2, 3 unknowns. So this is equation 1. So for F1, we can solve this by our coefficient of friction, which is F divided by N. So for block 1, mu is equal to 0.25. It's equal to F1 divided by NF1. NF1 is solved through summation of forces along the y-axis equal to 0 since there is no acceleration, no movement along the y direction. So for our Fy, that will now be equivalent to, let's have this direction as our positive. So we'll have Fy is NF1 and then our W1. So minus W1. No other Y forces, so equal to 0. So NF1 is equal now to WY, which is 15 times 9.81 times cosine of 45. Or NF1 is equivalent to, that's 15 times 9.81 cosine of 45. We get 104.05. So from here, we now can solve for F. So NF times 0.25. F1 now is equal to 26.01. So we could substitute this in the equation. So we now arrive at equation 1.8, which is equal to T, that is 26.01 minus 15 times 9.81 sine of 45. Or that is now equal to negative 78.04 equal to 15 EX. Okay, so we have 2 unknowns na lang. So we need one more equation. So where will we get the other equation? We get it from the 7.5 kilogram. So with that, we have again summation of forces along x equal to mass times the acceleration x. So this direction is positive. So what are the forces along the x-axis? We have negative tension plus frictional force 2 minus weight 2x. That's equal to mass 2 EX. Okay? So, hindi natin alam again si frictional force. So, this will again come from mu equal to mu2, which is 0.375 equal to F2 over NF. So, again, NF2 will come from summation of Fy. So, summation of Fy now is equal to 0. So, we'll have NFy 2 NF2 minus W2y, or NF2 is equal to 7.5 times 9.81 cosine of 45, or NF2 is equal to, we get 52.025 newtons. So from here, we can now solve for F2. So times 0.375. So F2 now is 19.51 newtons. So we substitute F2 in this equation. So we now have negative T plus 19.51 minus W2X is 7.5 times 9.8. Sine of 45 is equal to 52.02. And that's equal to M2 is 7.5 EX. So this is equation 2. So equating now equation 1, E and 2. Just write it here. So we have T equating them. So for equation 1E, that's T minus 78.04 equal to 15 EX. So EX is downward, so this should be negative. And then we have negative T, 19.51 minus 52.02, negative 32.51 equal to 7.5. So it's downwards also, so it's negative T sub. So eliminate this by addition. So we get now EX is equal to negative 78.04 plus negative 32.51. It's negative 110.55. Divide this by negative 15 plus negative 7.5. It's negative 22.5. And that is equal to 4.913. It's meters per second squared. So it's a positive value, meaning our assumption of the motion which slides down is correct. So this is our final answer. This is now the motion or the acceleration, but we are solving pala for the tension. So what we do is to just substitute our acceleration in any of the equation. So we'll have now T minus 78.04 equal to 15 times negative 4.913. The tension now between the two is 15 times negative 4.913 78. We get a value of 4.305 newtons. The tension is this one. Okay? So if you use the second equation, you should also arrive at 4.305. So we have 32.51 minus 75 times. So if you use the second equation, you'll arrive at 4.3375, which is almost the same as what we have computed. Nagkaroon lang ng discrepancy because of our rounding. Okay, so that's it for our examples for Newton's second law or the relationship between forces and acceleration. So we have here our references for more examples. You can read Dynamics of R.C. Hibbeler, or there are other examples found in your module. So thank you for listening.